Okay, today's lesson is 0-2b, which is the second part of operations with complex numbers. And we're going to actually use something called complex conjugates to write the quotients of complex numbers in standard form. Okay, so to divide complex numbers, we have to rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. Sounds like a mouthful. First off, the word you might not remember, rationalize, because we cannot leave a radical or the letter I, number I, whatever you want to call it, in the bottom, in the denominator. Okay, so we have to multiply the top and the bottom by the conjugate. And what are conjugates? You've seen those before. When you have two binomials, they look exactly the same, except for the sign in between them. One is minus and one is plus. Order that I have that doesn't matter. But this is the special case of multiplying that you should have learned earlier. A minus b times a plus b is a squared plus b squared. Because not only do we use this a lot when we rationalize denominators, but we also need to factor it, okay, when you get into other stuff with trig. Yay! So let's go look at these two examples that we're going to do. The first one is 1 plus 2i over 2 minus 3i. So the conjugate of my denominator, remember, I'm just going to change the sign in between. I don't do anything but change that sign. So I'm going to multiply 2 plus 3i, but I have to do the same thing to the top and the bottom. Okay, so when I do that, I actually like to start with the bottom, but let's see. So that's going to give me, remember, it's a squared minus b squared. And what is a in this case is 2, and b is 3i. So on top, I'm going to have to do the FOIL thing. So my first terms, 1 times 2. My outside terms, 1 times 3i is plus 3i. Inside, plus 2i times 2 is plus 4i. I don't know if I said that right. Plus 2i times 2, yep. And then plus 2i times plus 3i is plus 6i squared. Okay? Remember, I squared means I'm going to change the sign in front. So instead of having plus 6, I'm going to have minus 6. So now I'm going to simplify. And on the bottom, I have 4 minus 9i squared. I just squared both of those. And on the top, 2 minus 6 is negative 4. Plus 3i plus 4i is plus 7i. All right, so my bottom again, all right, that negative, that I squared with my negative 9 changes it to a plus 9. So my top stays the same, and that I have negative 4 plus 7i. But on the bottom, I now have 4 plus 9, which is 13. Okay? Now, you have to write it in standard form, so that's why you have to split this up. So you're going to put each top over the bottom. So that's going to give us negative 4 over 13 plus 7 over 13 times I. And that is how you write your answer. That puts it in standard form of a plus bi. So look at 32. 32 gave us a little bit of a punch with a radical, but you're doing the exact same thing. So I'm going to write the bottom. I'm going to multiply times 3 minus the square root of 6i. Now, I didn't have an example of this, but y'all, if there's ever a negative sign in front of here, it stays negative. You don't ever change it, okay? Again, multiply the top and the bottom by the same thing. So on the bottom, I'm going to have my two squares. 3 squared, a is 3, b is the square root of 6i, okay? And on top, I'm going to FOIL. First term, 2 times 3. Outside term, negative is 2 times negative square roots of 6i, so that's negative 2 square roots of 6i. The inside is negative square root of 2i times 3, and so that 3 is on the outside of the radical. It stays outside. So minus 3 square roots of 2 times I. And then when I multiply the last terms, okay, that is the square root of 2 times the square root of 6. I'm going to have a negative and a negative. And so that's plus the square root of 12 times I squared. Okay. Now, I want to tell y'all something in case you're not aware of it, okay? if you don't have a calculator that does this, is why another one of those reasons why I push ClassCalc, because they put this in there and I think it's an important feature. But you have to simplify this square root of 12. And in case you have forgotten, okay, if you go to ClassCalc and you type in square root of 12, okay, it gives you a decimal. But you can click on this decimal. It's on your phone. You click on the number and this will come up. But if you click on it and you see SQRT is square root, and when you put it, it will simplify it for you. Okay, if it doesn't simplify, for example, the square root of 15 doesn't simplify. You can even hit it before you hit enter, okay, but it'll give it right back at you. Okay, so great tool to have on your phone to simplify radicals if you ever need that. Okay, so that means the square root of 12 is going to become 2 square roots of 3. I squared is going to make it minus 2 square roots of 3. Okay, so on my bottom, I'm going to have 9 minus 6i squared. Okay, I hope y'all didn't forget when you square radical, it goes away. So that just becomes 6. Okay, and then on top, I'm just going to put the real parts together. Okay, and the real parts are anything without an I. So that's 6 minus 2 square roots of 3. And the imaginary parts are the ones that have the I on them. Okay, so remember 6i squared, the I squared changes the sign in front to be the opposite. So this is going to be plus 6, and 9 plus 6 is 15. And my top is not really going to change. Okay, I do have to separate it, and I'm separating it for the real part. And the real part is, again, those parts that don't have an I with them. And the imaginary parts are the ones that do. And so that's how you write that answer. Okay. Now, I threw some more examples in here because this is what you're going to see in your homework, and I wanted you to have an example of each of them. So, more examples. Solving equations, okay? When you see this, don't get fooled. 8x squared, 42 says 8x squared plus 120 equals 0. So you're going to subtract 120 from both sides and get a negative, and then you're going to divide x squared equal to negative 15. So the next thing you do is take the square root of both sides. So I hope there's a bell that goes off in your head, because when you can't take the square root of a negative number, that's why we're going to have an I in our answer. Square root always, an even root always gives us plus or minus. The negative underneath the radical gives us the I, and the square root of 15, I just showed you on the calculator how it doesn't simplify. So that's all you have. Simple. I hope you get those right. All right, the next example. Find the values of x and y to make each equation true. So what has happened here is there's two, this is a complex number and that's a complex number, okay? Because remember, our standard form of a complex number is a plus bi. So when you're trying to solve this, all you have to do is set the real parts equal to each other. So the real parts are negative 5 and 10, so I set those equal to each other. The imaginary parts are 3iy and 9i, negative 9i. Okay, but all I'm worried about, y'all, is the b. So the b here is 3y. Okay, that's why I wrote 3y, and b over here is negative 9. So you kind of ignore the I, not kind of, you do ignore the I on the next step. So when I divide both sides by 10, I get x equals negative 2. When I divide both sides by 3, I get y equals negative 3. And that is all you got to do to that. Okay? All right, last problem. Simplify. We are multiplying out 3 binomials. Okay? Y'all know from a long time ago, hopefully, that it doesn't matter the order that I multiply 3 things. If I multiply them, I can do the first 2 together, or I can do the last 2 together. So it does not matter if I had some conjugates, okay? Meaning if that was a 1, I would absolutely multiply these 2 first, because that would make things easier. But in the meantime, I'm just going to go in order. So I'm going to do this one first. My first term, negative 1 times positive 2 is going to give me negative 2. Outside terms, negative 1 times 2i is negative 2i. Inside terms, negative 3i times 2 is negative 6i. And last terms, negative 3i times positive 2i is going to be minus 6i squared. Okay, then I know y'all don't like to do it, but it's really important to carry down the rest of the problem. So I carried that down. Before I go to the next step, the I squared changes my negative to a positive, so I have plus 6. So my real parts, negative 2 plus 6 is 4. And then negative 2i minus 6i is negative 8i. Again, carrying down the rest of the problem. And now I'm back to kind of where I was in the beginning. I'm going to FOIL two complex numbers. So my first term is 4 times 1. And then I have 4 last terms. 4 FOIL. First, outside terms. 4 times negative 2i. Inside, negative 8i times 1. And last, negative 8i times negative 2i is plus 16i squared. Okay, again, I squared changes the sign in front to the opposite. So instead of having plus 16i squared, I'm going to have minus 16. So my last step is to combine my real parts. 4 minus 16 is negative 12. And then negative 8i and negative ai give me negative 16i. And that is all. So I hope you enjoyed that. If you have any questions, please don't hesitate to email us or contact us in some way. Thank you so much for watching, and y'all have a great day.